Here's a question. Is there a solid with infinite surface area but finite volume? If you've seen the title card, you'll know the answer is Gabriel's horn. This is a solid that's usually created by revolving the curve y equals 1 over x around the x-axis. We're going to show to you in this video just exactly how that's possible to get those dimensions. The surface area as given by the shell method is equal to 2 pi integral of a to b r of x h of x dx, with r of x being the radius and h of x being the height. R of x is equal to 1 over x in this case, and h of x is equal to the arc length, or radical 1 plus dy dx squared dx. dy dx in this case would be negative 1 over x squared, a would be equal to 1, and b would be equal to infinity. So our surface area would be 2 pi integral 1 to infinity of r of x h of x dx. As this is an improper integral of type 1, we can rewrite it as 2 pi integral 1 to the limit as b approaches infinity, r of x h of x dx. To make our lives even easier, we can then further rewrite it as the limit as b approaches infinity of 2 pi integral 1 to b 1 over x times radical 1 plus negative 1 over x squared dx. 2 pi integral of 1 to b of 1 over x times radical 1 plus negative 1 over x squared dx must be greater than 2 pi integral 1 to b dx over x, which is equal to 2 pi natural log of b. As such, the limit as b approaches infinity of 2 pi natural log of b is equal to 2 pi natural log of infinity, or infinity. As 2 pi integral of 1 to b 1 over x times a radical 1 plus negative 1 over x squared dx must be greater than infinity. As such, 2 pi integral 1 to b of 1 over x times a radical 1 plus negative 1 over x squared dx is equal to infinity. Thus the surface area is equal to infinity. Moving on to volume. Volume is equal to pi integral a to b of f of x squared dx. In this case, f of x is equal to 1 over x, a is once again 1, and b is once again infinity. So the volume would be equal to pi integral 1 to infinity of 1 over x squared dx. This is once again an improper integral of type 1, so we'll utilize the same steps we took for surface area. This leaves us with the equation of volume is equal to the limit as b approaches infinity of pi times the integral of 1 to b of 1 over x squared dx, or limit as b approaches infinity of pi times integral of 1 to b of 1 over x squared dx. From here we continue to evaluate the integral as normal, and we see that the integral is equal to negative 1 over infinity minus negative 1 over 1, which is equal to 1. As such, the volume is equal to pi times 1, or pi, and thus the volume is pi, which is a finite number, thus showing how Gabriel's horn is one such object where surface area is infinite and volume is finite.